Welcome to Out of the Blank.
Welcome to another episode of Out of the Blank podcast. I'm here with Dr. James Powell. It's nice to have you on the show.
Thank you. It's great to be with you. I look forward to speaking with you, Robbie.
Tell me a little bit about yourself and for the audience out there listening who might not know who you are.
Well, I'm a geologist by training. I have a PhD from MIT. I was a college professor and taught geology. And then I must have shown some administrative ability because I became a dean and a provost, and then I was the president of Oberlin College in Ohio and Franklin and Marshall College in Pennsylvania and Reed College in Oregon. And while I had full-time jobs, obviously being a college president, I never lost my interest in science. And so I tried to find ways to maintain and reflect that interest by writing books about science. And I've written several, and they're on my website at jamespowell.org. And the very first book I wrote set the trend for the rest of my writing, I believe. This was back in the early 1990s when the cause of the extinction of dinosaurs had been an unsolved problem for 150 or 160 years. And many people would have said that the death of the dinosaurs is the greatest unsolved mystery in science. And then some researchers came along and they said that at the level, the strata, the bed where the dinosaurs disappear, below this, no dinosaur fossils, above it, no dinosaur fossils. That level contained a rare element that is abundant in meteorites. And so these researchers hypothesized that a meteorite impact had killed the dinosaurs. That was produced. That theory came out in Science magazine, a very prestigious journal, in 1980. And so here I am in the early 90s. At that point, I was the president of the Franklin Institute Science Museum in Philadelphia. I'd moved on from being a college president. And so I really got interested in that, as any geologist would. And I knew that the hypothesis had evidence behind it, and yet I also had picked up just along the way that many scientists utterly rejected the idea of a meteorite strike killing the dinosaurs. So I decided to write a book about it. And I did, and I concluded that the theory was right. This was in about 1993, so we were almost 30 years ago. And it's not nice to say I told you so, but I would say that now, almost 30 years later, from when I wrote that, started researching that book, that theory has been confirmed many, many times over. And now it's about as close to an established fact as any theory can get, that indeed a meteorite strike killed the dinosaurs. And that got me interested in how science works. How is it that, and why, when a theory is brought forth, a new theory, it often happens that there's a group of scientists who accept it and another group who bitterly oppose it. And then this battle, these great debates go on among scientists, sometimes for decades. If you take continental drift, for instance, the theory that Africa and South America were once close together, touching each other, and then they broke apart and spread out to the side to create the Atlantic Ocean in between. That theory was proposed in 1912, and it didn't become accepted for almost 50 years, which is a long, long time in any field. Then finally, the evidence became so overwhelming that scientists had to accept it. So I got interested in this topic of how science is tested and how it evolves, which you were talking about just before we started recording. And so I decided to write a book about that general topic. And I wrote a book called 4 Revolutions in Earth Science, published by Columbia University Press. And in it, I addressed 4 great theories which had initially been rejected, but then later had come to be accepted. And one was continental drift, which I just mentioned. Another was the general idea that meteorites, objects from space, strike the Earth and cause geological change. Most scientists until the 60s thought that the craters on the moon, for example, were all volcanoes. And then as soon as the space age began and we began to send vessels close to the moon to take a picture and send it back, we realized that almost none of them are volcanic. They're all from meteorite impact. A meteorite traveling at supersonic, hypersonic speeds crashes into the surface of the moon and blasts out a crater. So scientists had to accept that, but they still denied that there were any terrestrial impact craters. Even Meteor Crater in Arizona, which some of your listeners, viewers will no doubt have visited, even the prototype of a meteorite crater was said not to be a meteorite crater until that became impossible too. Then the another theory that I talked about is man-made global warming. Most people are certainly aware today, nearly everyone who's paying attention, that scientists are virtually unanimous that human activities, namely the burning of fossil fuels, is emitting carbon dioxide that gets into the atmosphere and then raises global temperature. And it's a basic fact of physics that carbon dioxide absorbs heat rays and warms the Earth. But that theory was proposed around 1900. It too was rejected for 50 or 60 years. And then finally, the evidence came along and computer modeling began, using computers to model the Earth's climate, and it became clear. And now there's absolutely no doubt about it, not one iota of doubt, that man-made global warming is a fact and a dangerous fact. And then the 4th thing I talked about was the age of the Earth, which initially was thought to be in the last part of the 19th century, about 100 million years. But now we know it's 4.5 million years, 4,500 million years, 4.5 billion years. And that too was mightily resisted. So I wrote that book. It came out, I think, in 2015. And I'll switch gears slightly here and talk about a new theory that I wrote. If you can see this book.
Yeah.
There we go. I wrote this book about another meteorite strike, and that's the one that you were conversing with my colleague George Howard about recently.
So I want to kind of walk through these theories as well too, but I also want to just speak upon a couple of things that you kind of talked about. One, when we hear the rejection of science for the general public, people are, I find that at least me and a bunch of other people out there probably listening around the world are starting to question the term science more and more and more, only because people use it so flippantly. Science like you do is actual science. But when someone puts a hashtag or says something over a statement about Pepsi is amazing, and they'll say, trust the science, that's an abusive term to the word, and it kind of destroys it in a sense where a lot of people find themselves questioning what science is. Now, the best part about science is it's constantly evolving. As you might think you have a definitive answer in something, 10 years later, 20 years later, that can change, and that's okay. But when it comes to these theories or these things taking 50 something years or however long to finally get passed, a lot of that does come in with egos. And a lot of that is because certain scientists that are pushing a theory really want their name and them to be attached to it, to be remembered by, just like every single person wants to know where they came from. And every single person wants to know what's going to be the thing that wipes them out. That's kind of why I'm getting interested in the whole like extinction event type things. Now, I had George Howard on the show, and he's how I came across you through the younger Dryas. Is it? I'm going to say it wrong again. He's corrected me so many. Dryas, yeah, younger
Dryas.
Dryas theory. And then also I had Peter Ward on as well too. Talk about is it Cretaceous or Cretaceous?
Cretaceous, yeah.
Yeah, Cretaceous extinction event. So when the thing that they both kind of talked about as well too, that I kind of brought up, is the fact that it's when you want to be remembered for something, you're more than willing to dismiss anything only because you want to be focused in the general direction of the progression of society as well too, and you want to be one of those people who are helping it progress forward. But when I came across your journal talking about that it might have been dismissed a little bit too early, the younger Dryas impact hypothesis, that to me is a sign of someone that I want to look up to, not trying to like blow smoke up you, but and a sign that someone I want to talk to, because that is very, very hard for a lot of people to do, to admit that, hey, even if it wasn't you that dismissed it, if you just said like, hey, we should take a second look at it, that's showing that everyone's invited to the table, even the theory that gets tossed way out of left field. And I think that's how you got to think about everything. Water is H2O. We all agree upon that. But at the same time, someone who has a different perspective or another type of idea on something is not invalid in their choice. You still talk about it, but there's a general consensus that the public has to get to. And that's kind of like the weird grounds with, I would say, the term science, for instance, because you want to progress humanity forward, but at the same time, it's like we're all trying to figure it out at the same time. It's like unraveling the same puzzle. Now, the extinction events, everyone in school, at least for me, was a meteor wiped out the dinosaurs, and then that was it. That was like the blank slate that they gave. Now, you mentioned one, which was continental drift. Now, the way that I've heard about that was that they kind of saw how all the pieces look like they fit together, like the North America, Africa, all of them look like if you brought them together, they kind of would fit together. I'm guessing that was the time period back then that seemed like a logical kind of conclusion to how everything kind of became how it is.
Yes, well, let's talk about continental drift, but I generally agree with your
Speech,
remarks.
my
To
speech.
say trust the science, okay, well, I hope people will trust the science, but science is trustworthy because it uses evidence. And if the evidence is correct, that you publish is incorrect, let's say that you publish, some other scientist will immediately go out and prove that it's incorrect. So science is sort of honed and evolved until what's left is as close to the truth as you can get. The idea that the continents might have been together goes back to the very first maps of the world that were made, and I think this was in the 1600s. So it goes way, way back hundreds of years, because as soon as they made the maps of the world, they could see that Africa and South America would fit together like two pieces of a jigsaw puzzle. And so that people thought maybe they were once together, and then somehow they got ripped apart. But that was just speculation at that point, and there really was no evidence for it. As someone pointed out once, that Italy is shaped like a boot, right? If you look
Yeah.
at Italy on the map, it looks like a boot,
Yeah.
but it wasn't a boot, right? It's just a coincidence. It's just an artifact of where sea level happens to be. So a German scientist named Alfred Wegener proposed in 1912 that the continents had been together, that the Atlantic Ocean had once not existed, But he didn't just say that they match up like a jigsaw puzzle. He produced a whole book full of evidence for that. But at that time, back around 1900, geologists were operating under a principle that they call uniformitarianism. Uniformitarianism. It's one of the longer words in the English language. But what it meant is that the same processes that we see going on today, rivers are flowing, they're eroding, depositing, glaciers are moving across the land and then melting and retreating, volcanoes are erupting. Most of these are very slow processes on our time scale, and they believe that that was uniform throughout Earth history, that there were no catastrophes and continents being ripped apart and pulled away from each other would be a kind of a slow motion, gigantic catastrophe, or a meteorite striking the Earth and blasting out a crater and killing the dinosaurs. From the dinosaurs' point of view, that would certainly have qualified as a catastrophe. So geologists had this principle that they had, in a sense, almost sworn allegiance to, not literally. And I grew up as a student, so to speak, learning that. And so continental drift contradicted that. That's one thing. And so in the 20s and 30s, geologists thoroughly rejected continental drift, and they bitterly attacked Wegener, who turns out to be a great scientist. And he was right. And a great man, really. I've read a wonderful biography of him by Mott Green, Green. And then in the 50s, scientists began to study the Earth's magnetism. And this was a result of instruments and techniques developed during World War II. It's an interesting fact that a lot of the advances in science in the 50s and 60s derived from something that people had done during the war for military purposes, but there was this sort of fallout, advantageous fallout, you might say. And it turns out that when a rock forms, when a rock is a lava comes out of a Hawaiian volcano and freezes, solidifies, it has minerals in it that act like little compass needles, and they point toward the North Pole at the time that rock formed. So if the continents had moved,
they would have moved upward.
Yeah, if you go back and look at a rock that's 200 million years old and you measure where its compass needle points, right? Mm-hmm. Let's say, put it the other way, if the continents have not moved, that 200-year-old rock will point to today's North Pole, right? It's never moved. It's in the exact same place it's been for 200 years. It's going to point toward the North Pole. But it turns out older rocks did not point toward the North Pole. Rocks from Europe pointed to the pole in one place, and rocks from North America another place, India another place, Australia another place. And so since there's only one North Pole, this meant that the continents had moved, and each continent had moved differently. So here was a piece of quantitative evidence, a measurement, and you could repeat that measurement as many times as you want to. That's a key thing about science, is that measurements and data are replicable. You publish a set of data, some other scientist can go out, and if he does or she does the experiment the same way you did, he or she will get the same result. So all of a sudden there was actual data, and you couldn't just wave the data away because it violated uniformitarianism. So that makes a couple of points. One is that data rules, but also that in the 30s, 40s, or even early 50s, there really was no data to show convincingly that continental drift had occurred. If you didn't want to believe it because you believed in uniformitarianism, there was nothing that would make you believe it. And the same thing was true of meteorite impact and even global warming. There was basically no global warming to speak of. It wasn't really noticeable until the 60s and 70s. And so now then it became very noticeable. And since then, global temperatures have gone up, 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 up. So that's a little bit of background on this.
And with the second theory, the idea that a meteorite or that could have hit or could have an impact, for instance, why would people dismiss a theory of like a comet or some type of asteroid hitting the planet when I get it because like maybe the moon volcano idea, but then they figured out they were actual craters. But to think that we're a planet in a solar system we don't get to see outside our atmosphere, we don't get to see out into space. Our eyes just can't. But floating debris that's constantly flying around. I mean, we have satellites that fly all the way time. Maybe this wasn't the time period that they were having satellites get launched up into space, but at the same time, you got to look at like these giant craters that we have. To me, I mean, I get down a weird kind of like, I wouldn't say conspiracy rabbit hole, but I mean, to bring back the continental drift, if you had a comet or an asteroid hit and it all broke apart, I mean, I can see where they're all not heading up north. I guess that's just my thoughts on that. But the idea, like planetary defense, is one thing that I'm pushing for as in my interest, I would say, only because the fact that we haven't been knocked out by another asteroid or some type of thing, even though we have defense systems, or if we see it coming, we're able. What are we going to do though? All of our eggs are in one basket. That's why, like, I don't mind whole space colonization, even though I would rather explore the oceans. I would like to explore more of this planet because I know it holds a lot of secrets, and I don't want to see it just get wiped out without us discovering it all. There is a fear for me and a worry. The more I start diving into planetary defense and talking to astrophysicists who are studying the sky and everything as well, it's a real fear in a sense where, yeah, something could just randomly come into our atmosphere. We would have no time or preparation to be able to handle it. You know, something could slip under our radar. It doesn't even have to be that big. It could be the size of a SUV. It can be the size of a house in a sense. Coming from our atmosphere at such a high velocity and high speed is going to cause some damage. Some people are going to, get killed from that. So I look at it as an aspect of like, is it one little rock? Is it one giant rock that could literally change the face of our earth in a sense? I mean, if anything, I look at our atmosphere, not just our atmosphere, but the planet that we're on. It's like a 7-year-old. Like if you keep feeding them candy, he's happy, but then you take it away and put them in punishment or something like that, then they get really upset and throw a temper tantrum. I mean, it kind of links into global warming in a sense too. I don't want to jump right into that if you have an answer for anything.
Okay, well, you're making some very good points. We live in a swarm of objects flying through space. And these objects are traveling at 20, 30, 40,000 miles per second. They're traveling at hypersonic speeds, and
Can't even imagine it.
Even a little particle has great energy. And so one worry is that if even a small meteorite, say, struck in the Atlantic Ocean off New York, it wouldn't create a crater perhaps, but it would cause a tsunami. But let me go back in history a little bit here. I have written a book about the moon and the long controversy over the origin of the moon's craters, and also on the origin of the moon itself. And I have this book out with a publisher now, and I hope very much they will decide to publish it. But if not, I'll try to find someone else to publish it. So I've thought a lot about this, studied it, written about it. And it was very obvious that the craters on the moon are not volcanoes. They look nothing like volcanoes on Earth. They're totally different in almost every respect. And yet, in the 1800s and on into the 1900s, the 20th century, a kind of groupthink set in where geologists and astronomers all believed or said they believed that lunar craters were volcanic. it's hard to understand, and it's not scientific. This was just an opinion they had based on next to nothing. But you also have to remember that we did not have a close-up look at the craters of the moon until 1964. And that was when NASA launched a mission. I remember it. I'm that old, quite well. I was a mature adult in 1964. Now I'm an old adult. They sent the Ranger mission to the moon, and it had a video camera. And so it came zooming into the moon. And just before it crashed, well before it crashed, it started taking video pictures. And when they sent them back, you could see that the moon had big craters, and inside those were smaller craters, and inside those were smaller craters, and inside those were smaller craters. And so there were craters of every size down to ones, I don't remember what the resolution of Ranger was. Let's say it was 10 feet or something like that. That would be in the range. So you don't have, on Earth, we don't have volcanoes, small volcanoes 10 feet wide, right?
Mm-hmm.
So that was when the evidence came that the lunar craters are due to meteorite impact. And we're in the same region of space as the moon. So if the moon has lots and lots of impact craters, in fact, every inch of the moon's surface has been struck by a meteorite at least once, and many times. So they're constantly being pulverized. Constant means over geologic time, 4.5 billion years, constantly being pulverized by these incoming impacting meteorites. So if that's true of the moon, the Earth is bigger. We have a stronger gravitational pull than the moon. We have 6 times the gravity of the moon. So there just must have been impact craters on the moon. But for scientists to accept that, the ones who denied it, they had to give up something that they had long professed and long believed. Now, if you and I have a belief, let's say we believe that Power of the Dog is going to win the Oscar, right? We believe that. Well, we're either going to be right or we're not. And if we're wrong and some other movie wins it, oh, okay. But if we wrote scientific papers and presented all kinds of evidence, and we did this for 40 years, saying, of course, so we wouldn't know about Power of the Dog, but saying something, taking a position. If you spend your entire professional career saying there are no impact craters on the moon, you put it in writing over and over, it's very, very hard to admit that you were wrong. We all have trouble admitting we were wrong. But if you put it in writing and sign your name to it, and you get credit for that, and you become a tenured professor, it's very difficult to turn around and say, I was wrong. But the really great scientists, I'm holding my finger up here, the really great scientists are the ones who say, you know what? I was wrong.
Yeah.
There
It,
are meteorite impact craters on Earth.
it's more than, I think people look at it from like, oh, is it just a person that can't get over their own ego? Is that why they won't admit they're wrong? I'm like, in a sense, that is it as well too. But also the way a lot of them are probably thinking about it is from a professional standpoint. See, people want to look at the doctor or the surgeon who has 74 surgeries and 74 of them are successful, and they got 0 that went bad. Nobody wants a bad surgeon, but you're basing it off the wrong thing. It's not necessarily about the record to me. And it's like, it's a movie quote, so I'm not going to steal it, but it's from Doctor Strange, where he goes to take a surgery and he goes, oh, this is a tumor in their spinal cord. This is an unwinnable surgery. I'm not even going to tarnish my record in that aspect. I don't want that happening. And that's what happens when you base all people's decisions, or your own mindset, I would say, of who's the best scientist off the basis of their record. It's about the shots that they do take, knowing if they're impossible or not, or if there's something of that sort. Now, that doesn't mean that you want to listen to every person that might believe the earth is flat, but in a sense, it's like they're not there's a professional aspect that kind of seems to be a lot of very competitive, a lot of very, I got to be 100% right. I'm not going to go in on it if I'm not sure. I have to be 100% positive. That's good for a scientist, sure, but when that leaks into the public, it starts to sway opinions and dissent, and then next thing you know, that person could have been wrong, and they'll still double down on top of it. I mean, that's a lot of what we face today. People not admitting that they're wrong in a sense. They just want to double down on a lot of things. And honestly, I give more respect to the people that do admit they were wrong, because we don't have any definitive answers in life. As much as we know now, and we call it definitive, 100 years from now, like you were saying, their data back then wasn't good. 100 years from now, they're going to look back at us and say our data wasn't good. They're going to be on a whole different thing. They're going to be going deeper, depending on if they go to the moon or not, or like research space or not. If they, hopefully they still research here, because there's a lot of secrets here I would like to know about. But like even climate change, for instance, that's a topic that I've talked to climatologists, I've talked to so many people involved in this thing, where I've seen from both perspectives that it's not happening and that is happening. Now, I believe change is happening. Obviously, climate change is happening. But with these weather fluctuations, I started thinking of like this idea that I heard about, which they said it's happened before. I don't know if that's true or not. Maybe you can confirm it, but a polar shift. Like it seems like our polars, I guess, switched at some point, if that's a conspiracy theory or that's some type of myth that's out there. But you're seeing like the way I've kind of been explained that the earth isn't flat from my friends. And I have a friend who's a flat earther. It's not me. I'm not a flat earther, but I have a friend who's one. And I had to ask my friend who's an astrophysicist. And I was explaining how come they bring up the point you can see the sun and the moon at the exact same time when you're on this thing. Does that mean it's flat? And they say, no, we're on an axis. So I'm wondering if we're just at this kind of like diagonal type thing spinning around, you see the direction I'm kind of doing here? But if we're at this kind of spinning point, is it possible that, I don't know how long it takes, but it could shift? Like winter here is like summer in Australia. And I kind of look at it on a concept of, we're having snow. Like it's 60 degrees as we're recording this. Last week it was 26. Like, is that climate change? Yes. Is that global warming? I mean, if there are people that are saying it's not global warming, they're going to base it on that evidence. So I'm trying to understand, has this just been a topic that's been littered with just scaring? I have no clue, because that's all I see on media is talking about climate change. You're going to die tomorrow. And I feel like they've been saying that forever, and it doesn't happen. Now, the issue with that is you have people that just go, yeah, sure. And then they keep doing it. They keep driving their diesel trucks and they're throwing whatever. But at the same time, when I was a kid, it was like if you use nuclear energy, you were going to grow a third arm on your back or something like that. And then I go onto the energy.gov website and they tell you the most, I guess, the best type of energy is nuclear energy, where I start going, the government's lied to me before. Are they doing it again, or are they being honest and no one knows about it? And then this is where we get where I'm standing at with the general public, where it's like, what's to believe in? And then now people aren't taking things at face value, which I say is a danger. That's why I like listening to people's scientific theories. Now, Peter Ward is a big person on it, global warming. The planet is warming 100%. I'm with him on that too, because he brings up a lot of strong points as well too. But it's always focused on our fossil fuel consumption. It's always focused on these things. And I start going like, gas is now $4. I go, well, actually it's 4.20 now, which is ironic, but if it's 420 and they just passed an electric car bill and you're seeing more electric cars become normalized, I'm like, are you just raising gas prices up to where people see the most affordable option is now to get an electric car? So you're just cutting off people from having a chance of driving a normal car. Now that could be a conspiracy theory. We can say that, but I look at it like, I don't put it above the government to sway their opinion or do whatever. Now, if it's for the protection of the earth, how do I know if they haven't been honest about it before? And that's where we get the standpoint back to this whole long rant that I'm trying to say is, there's a lot of people confused on what the hell is going on when it comes to our planet, and they don't have easy contact or easy information that you have as accessible as you do, because they haven't worked in the field. And I consider that a problem with the education system as well too. They don't make jobs like this like as easily accessible, I would say, unless you're going to college. And for a lot of people, they don't end up going to college. Also, when it comes to the source of information, which is why, like I said, I'm a very appreciative you've done my podcast as well too, is because it opens it up to the public. You become accessible, and that's what people want. They want to hear it from you. They don't want to see a talking head do it. Maybe some people do. Some people want to see Tucker Carlson rant about whatever, but not me. For me, I want to talk to the actual people and learn it from your experience as well too. And that's any scientist, someone who says that global warming's bullshit. Let me hear it. I want to hear and sort it out for myself, because I guarantee to you it's about the data that's in your own head. And the data that you have is going to be everything that you focused up to that's brought you to the point in the thinking that you have now. And that's valuable. But it's about an open conversation, like I was explaining to George Howard on my show, is that when we're looking at the dismissal of the younger Dryas impact theory, and then now it's starting to look like it might be a possibility, or it's more likely that this is actually the thing now. Just the idea that it was dismissed and now it's taken us this long loop around or 180 to get back to that point, that has been every problem for every single innovation, anything that we've ever really experienced on this planet. And maybe that's just the human species. Maybe that's just us in general. But I honestly think that it's a lot of the way society's set up. I feel like for now, for instance, an educational career can easily, even if you have tenure, that's on like I guess the line I would say, depending on if society wants to reject you or not for the things that you say. Science is not being science anymore, and it's not science's fault, like you were saying. It's the people who hijacked the term. And it's a lot of what the words we say, they have bigger impact than the younger Dryas impact hypothesis. Like it really affects a lot of things. And that's where I get scared as a person who doesn't have kids, but would like to. What's the future going to hold? When I look at my nephew, if your grandkids, for instance, what are they going to be growing up in? A world that just doesn't know what to believe in, a bunch of people not trusting anything? You need trust, but you have to come honest with the things that you know and the things that you don't. And I feel like a lot of researchers will tell you the things that they do know and point it all to that and sway it maybe in that direction without telling you the things that they can't explain. And then when that gets debated or gets into an open discourse, I hate those, because you're not just showing that this person can't explain this, you're trying to insult them. And I'm like, as people, as a human species, we should be more intelligent to want to have a conversation like me and you are having, where we're just talking and we're trying to understand and we're figuring out where this path or direction of the conversation's going. But at the same time, we're learning from each other. We're sharing experience. Hopefully, I'm restoring your faith in the younger generation just on the basis of the things that I say. But this is important things that I feel like the future needs to take hold of that we really don't. We put on the back burner. We put the cool UFO topics up top. That's interesting. I think that's fascinating too. But when it comes to the thing that we're literally walk out into every single day, we stand on top of, and it seems like with the amount of information out there, there's still a large consensus that doesn't know much about it. Not saying you, but the general public who might be more interested in UFOs or The Bachelor or whatever you want to say that's on TV. And I feel like that's a disservice to not only you, but also the field that you work in, because it's a very important thing. Being able to date certain things. I mean, that's why archaeologists are important as well. There's a whole field of people out there that are in some aspect people don't want to hear from, only because I don't think they realize how freaking interesting it is.
Yeah. Well, there's a lot to chew over there. One, I'll just pick up on a couple of points. Yes, I have grandchildren, and my main concern with global warming is not that it's going to affect me, because it's a process that goes on over decades, generations, but I'm really concerned about the world that we're leaving for our grandchildren. And if there's any chance that we're going to leave the world in a much worse place for them, then I would like to see us correct that. And of course, the main threat is not meteorite impact, although you're right. We live in a swarm of incoming objects, and we have to find out where they are when they're arriving and figure out how to ward them off. But the main threat, of course, is global warming. So I'm probably going over the same ground that Peter Ward and maybe others have gone over. But let me just briefly review the evidence for that, for global warming. We have known since the 1850s that carbon dioxide molecules in the atmosphere preferentially absorb heat rays that are rising from the Earth. And so they prevent those heat rays from escaping, and it's like a blanket that covers the Earth. So that's a physical fact. There's no doubt about that. It's not arguable. We know that since, let's say, the late 1890s, 1900, global temperatures have risen over 1 degree centigrade, which is 1.8 degrees Fahrenheit. That is a known fact. It's based on going out and looking at your thermometer, so to speak, except on a global basis, and seeing what it says. So if I lived 100 years, every day I went out and looked at my thermometer and made a graph and it went up, 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 well, there's no arguing with that. But the question is why? Why has global temperature risen? It's not the sun, because the sun has basically been stable and unchanging during the last century or 125 years or so. So global warming the Earth has warmed, the globe has warmed, and it's not due to the sun. There must be some other reason. We know that when we burn coal or oil or natural gas, we convert the carbon that they contain into carbon dioxide. And so as the industrial age has moved along and the coal age, and now we're in the oil age, and maybe someday in the electric vehicle age, which would be a good thing, the amount of carbon dioxide in the atmosphere has gone up. That is an established fact. We've been measuring very carefully the amount of carbon dioxide in the atmosphere from a station in Hawaii, at the top of Mauna Loa in Hawaii. And since 1958, the carbon dioxide level has never gone down once. It's gone up, 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 and now it's wherever it is. I don't know. I haven't looked at it lately. 410 parts per million, whereas in 1958 it was something like 300 parts per million. So I'm talking about known, measured facts. Now, here's a critical fact that I happen to know about given my scientific background, but I think I can explain it. One could argue, and people have argued, that yes, the Earth is warming. Yes, carbon dioxide is increasing, but the temperature rise is caused by something else. The carbon dioxide increase is not due to human activities. It's leaking out of volcanoes or coming from somewhere, but it's not due to me driving a gas-powered vehicle or burning coal or fuel oil. But that's not correct. It is due to human activities. And the way we know that is that carbon has isotopes, which you will remember from some science class back in high school somewhere. Carbon is an element. It has 3 varieties, carbon 12, carbon 13, carbon 14. And the ratio between these isotopes, fingerprints, or it's like the DNA of carbon. It tells you where the carbon came from. And when we look at the carbon isotopes in the carbon that's been added to the atmosphere, the fingerprint tells us that this is ancient carbon. It's hundreds of millions of years old. It's not carbon coming from some process on the Earth right now. It's ancient carbon, it's fossil carbon, it's fossil fuel carbon. So that ties the whole thing together. And even if people don't accept that, which is the best science I know of, then aren't people willing to take a chance that I and other scientists just might be right? they think we're wrong, but what if we're right? Then our grandchildren's lives are going to be greatly inferior to ours. And the chances that I had as a youngster when I was your age, and that you have, and your children who you say you want to have someday, and their grandchildren, their lives, the quality of their lives are going to be compromised. So global warming, man-made global warming, is as much a fact as we know of in science. And people are just fooling themselves if they don't accept it, and they're threatening the quality of life of their grandchildren, and they ought to think again.
It's Peter's Medea hypothesis, that he talks about the human species wanting to end itself in a sense of global warming, for instance. I think it really doesn't sink in with a lot of people to change, because the way that they talk about it is it is the long game. It's not going to affect you per se, but it might affect the future generations. Well, if they don't know those future generations, they're not going to care. You don't have a face to attach emotion to. You just hear an idea or a concept, and that person can be like, well, what if I don't want to have kids? And it's like, well, that's not the point. You got to think of the future, what you're leaving behind, in a sense. I think that's why it hasn't woken a lot of people up to it. Like I said, it's a complicated topic. I mean, as much as you can easily explain it, just for basic understanding, and for a lot of people out there, everything they see is talking about cow farts or cow burps. And I'm like, if you look at a lot of those graphs as well, too, they're not basing that methane production to other industries and coal power plants and anything of that sort. They're basing it off of a person that rides their bike. Like, that's what they compare it to on a bar graph. So they look somewhat close together, but one's kind of dramatically kind of thrown up in a sense. And it's like, well, if you base it to industry standards, you would think the best way to fix this issue would be to talk about the black smoke that's coming out of a lot of these factories that we're producing a lot. And that's all over the place. Just because you can't see it, depending on where you live, doesn't mean it's not happening. And that's why I'm pushing for a renewable energy. I'm just looking for whatever that basic concept is to be able to help out with global warming as well, too. I don't know if it's necessarily getting an electric car. I feel like there's probably a better method than having another thing. But I mean, that's the one we have right now, so that's our best option.
Okay. In the time we've got left, I'd like to switch to the topic we
Yeah,
we
yeah,
started out with, which is the Younger Dryas impact hypothesis.
yes.
And
Don't rush. I got as much time as you need. I have
okay,
nothing to do today.
okay. I have something coming up, but I've got certainly a few time to talk about that.
Perfect.
13,000 years ago, North America and South America, the world was populated by people. Writing hadn't been invented yet, and so forth, but there were primitive paleo people on every continent. The earth was warming, and then suddenly, at about 12,800 years ago, the Western Hemisphere, North and South America, especially North America, let's focus on that. Suddenly, in other words, the glaciers that the ice ages were waning, the glaciers were melting, and then 12,800 years ago, temperature suddenly plummeted, and the temperatures went back to the ice age conditions. And they stayed there for about 1,300 years. And then they began to warm again, and they've been warming ever since, and especially warming in the last 125 or 150 years because of man-made global warming. So when this event happened, it's recognized by a layer that, for reasons I don't need to get into, scientists call it the Younger Dryas. That's a layer in the soil that marks this 1,300-year cold period. And so the question is, what caused that? It had two great effects. At that time in North America and South America, there were horses, there were mammoths, mastodons, there were giant sloths, there were giant bisons, there were camels, there were llamas. It was like what you see in the Serengeti area of Africa now, filled with animals, except these were animals, many of which we don't know anymore because they all went extinct. Horses were present throughout North and South America in the untold scores of millions, huge numbers of horses. And then almost in a geological instant, they all went extinct, and there was not a single horse left in the Western Hemisphere. But of course, then we got horses. How did that happen? Well, the Spanish conquistadors, Cortez, when he came over, they brought horses with them on their ships, and those horses escaped or were stolen. So eventually, horses built back up, and the Native Americans in North America themselves had huge horse herds a couple of 100 years later. So what caused that extinction? It's like the extinction of the dinosaurs. Here's some creature, in this case, many creatures, that seemed to be doing very well. The dinosaurs were the kings of the earth. Horses were seemingly indestructible, and I say that as a horseman, greatly adapted to their environment. All of a sudden, they were all gone. Then in North America, there was a Paleo-Indian culture called the Clovis Culture, and it existed throughout North America and down into Venezuela and northern South America, possibly farther, but at least those are the areas where their artifacts have been found. The Clovis made these beautiful spear points that are almost like works of art. I have one on my wall over here I'm looking at right now.
It's funny. George said the same thing. Yeah, George has one too.
You go to a museum, you will see these beautiful things. This is art, not just a tool to do something. Of course, they use them for killing big mammals. The Clovis culture disappeared. That is not the people, but what they call their toolkit, all the artifacts, the spear points, all the things that they made, they suddenly disappear from the record at that time. And so here is another mystery. Perhaps in a way, it's as important as the extinction of the dinosaurs, because when the younger Dryas happened, the cool period happened, there were people who looked just like you and me. Maybe they were slightly smaller. They probably weren't many as old as me, but there were modern humans were walking the earth, and they saw whatever happened at that time. Whereas the dinosaurs didn't kill any of us, although it did kill most everything else and opened up a niche into which a little mammal entered, and that little mammal 65 million years ago is our distant ancestor. So the Younger Dryas impact, Younger Dryas is a mystery. Then in 2007, a group of scientists, I don't know if George was involved then or not, but he certainly is now and came later. They found a lot of little microscopic beads, glass beads in the Younger Dryas layer. And in North America, for instance, there are dozens, maybe there's 100 or more Younger Dryas sites where you can go collect from the Younger Dryas. You can see it.
He pulled some up on the show.
Yeah, good. These little glass beads. And these are typical of impact. They're found in the layer where the dinosaur disappeared. We find the same thing.
Is that tritonite? Is that tritonite is what it's called? Tritonite?
Tritonite is a mineral that they otherwise only find in a nuclear explosion site. So, but there's a lot of different evidence. I don't need to go into what all the evidence was. Sounds like George covered that. And so this group of people proposed that there had been a comet strike on the Earth that had thrown up a cloud of dust and particles that had blocked the sun and caused temperatures to fall. And they call it an impact winter, in the way that a nuclear global nuclear war would cause a nuclear winter. This is an impact winter. And somehow, although they don't know exactly how, this must have been related to the extinction of the big mammals, the horse, the mammoth, and so forth in the Western Hemisphere, and the disappearance of the Clovis culture, because they all happened at exactly the same time. So it was proposed, and then right away, just as happened with continental drift and dinosaur extinction, a small group of people rejected that hypothesis. And they didn't just reject it, they made fun of it. They denigrated the proponents of the hypothesis, and they did their own studies of the evidence, the glass beads that George showed you, that occur in the tens of thousands, millions at the Younger Dryas level, huge numbers of them. They're very microscopic, very small, 100 microns or something. A micron's a 10 to the -6 meters. Tiny, tiny things. You can't see them with your naked eye, but if you look at them under an electron microscope, you can see them. And so these people went out and did the same experiments, and they said, well, we can't find these glass beads. We went to the very same Younger Dryas layer where George and his colleagues say they found these glass beads, and they showed pictures of the glass beads, photographs of them, right? They didn't just claim it. There they were. There was a photograph. Well, this other group of opponents said, we can't find these glass beads. So at that point, the scientific community had a choice. One group said, here is positive evidence of an unusual event. We find these glass beads at this layer where all these things happened, and that can't be a coincidence. It's got to be some kind of cause and effect. So there's positive evidence, right? Then the opponents say, well, we can't reproduce that positive evidence. We can't find that positive evidence. So they had, you might say, negative evidence. So if you think about it, positive evidence, including photographs. If I show you a photograph of something, like if I went over and got that Clovis point that I was sitting on my shelf over there, I got it for a birthday present from my children, so it's a precious object. And I held it up and I said, Robbie, do you see this? This is a physical object that I'm holding in my hand, right? Here's a photograph of it. You're going to say, yeah, okay, it exists. There it is. But these people, the opponents, said, no, those physical objects don't exist. So the logical thing to do, if somebody said, well, you know, Powell didn't really show you that, or that was a fake or something, well, okay, there's probably a conspiracy theorist or two out there who would say that. They may be listening. But you wouldn't say it. You'd say, look, the guy held it in his hand. He showed it to me. It's a physical object. It's a thing. You can touch it. It's solid. And not only that, it's beautiful. And so that led to what I call the premature rejection of the Younger Dryas impact hypothesis. And when I say premature rejection, excuse me, get a little sip of coffee here.
I just had a question on the evidence, even if they showed and it was rejected. Do you happen to think if that was maybe if there was an open conversation, more maybe I guess they were the people that might have rejected that evidence, if they would have known the people who were supporting that evidence a little bit better, that there probably would have been an open acceptance rather than a rejection? Because I know science, a lot of people are working on their own different things. It's hard to associate and be conversative and all that as well too, mostly because you're focused so much on your research in a sense.
Yes, absolutely. But that didn't happen, and that's a failing of science. The Younger Dryas layer, in some places, it is extremely hard to identify. You're looking at an outcrop, let's say, like a small cliff, right? And somewhere in the middle of that cliff is this thin layer, maybe it's a quarter of an inch thick. That's the Younger Dryas layer. Sometimes it's obvious, other times it isn't obvious. So what they should have done is gotten together, gone to the same site or sites where the proponents would say, well, okay, here's where we collected our specimens. And then the people who turned out to be the opponents would sample that very same layer. But now remember, I said earlier, these things are submicroscopic. You have to handle them with extreme care in a laboratory. You could flush them down the drain if you're not careful, or if you didn't actually sample the layer, you wouldn't find them. But I guess the essential point, Robbie, is that if I find something that's a physical object, right, and I tell you where I found this thing and that there are a lot more of them there, right, and you go out and you say, well, Jim, I can't find those things, right, and we asked Peter Ward or somebody, some neutral person, who's right? They're going to say, well, Jim found these objects. He took photographs of them. He analyzed them chemically. Robbie says he can't find them. Well, Robbie must have looked in the wrong place, or he must, since they're so tiny, Robbie must have made some mistake somehow in his procedure. We don't know. We don't want to accuse Robbie of anything, but let's do the whole thing again. Let's Robbie and I and Powell get them together and have them go to the same site. Well, they didn't do that. They made one effort to do that, and somehow it didn't work out. And so you had these two rival camps, the proponents and the opponents. And so what I tried to do in my article, which was in a journal called Science Progress, people who are interested can online search for it, premature rejection in science, in a journal called Science Progress. You can Google it, and it's open access. You can get it and download it. And so I tried to show that this hypothesis had been rejected unfairly on the basis of negative evidence. In other words, no evidence trumps positive evidence, even photographic evidence. That's not right. It shouldn't be that way. So I didn't claim that the hypothesis is correct, certainly, but I said it needs to be reconsidered. And then I listed a lot of evidence for it. Different, not only the little glass beads, but all kinds of other evidence. Personally, I have no doubt that it is correct. That's my opinion, but I'm not going to say that in a peer-reviewed scientific article because I don't need to say that. You don't have to prove that a theory is correct. You just have to show that it's better than any alternative theories.
Yeah, it was 42 pages. I mean, including references as well too. But it was thoroughly well done. With the pictures and graphs as well too. You showed a good analysis of your point as well. I think that was very clear throughout the article. But with your book, for instance, what does your book try and say? What is your book about? I understand it's about the impact hypothesis, but
yeah, this is the book. It's called Deadly Voyager: The Ancient Comet Strike That Changed Earth and Human History. It's an ebook. It's on Amazon. It costs $10. You can find it at my website, jamespowell.org. And it is an overall review of the Younger Dryas impact hypothesis, where in my article, I didn't really talk about the Clovis people, the extinction of the horse. I just mostly talked about the scientific data that showed an impact happened. But in the book, it has much wider coverage, and it's aimed at the general public, not scientists. And so I'm happy to say that it's up about 4.5 stars out of 5 on Amazon, which is very good.
Yeah.
You always find people who, whatever you look for on the internet in the way of ratings, you always find very poor ratings and very good ratings. And I have some poor ones. And as far as I can see, they're from the longtime opponents
It's easier for
of the
people to,
hypothesis.
about say it's easier for people to leave a bad review than a good one. That's like when you go to a restaurant, you just expect the food to be good. You don't expect to like leave a, like a honest 5-star review. You just, if you only rate something if it's bad. I used to work at a hotel and that's always what we got.
Yeah, I worked in hotels too long ago. But yes, you go to a restaurant or you look on Yelp and there's a restaurant that gets lots of 4s and 5s, but then there's a 1 rating that says the waiter was slow,
Hmm.
or the way I didn't like the waiter, the way the rater treated me, or there was a something, some little something. So you have to take them with a grain of salt. So, but it does make a point that uh, if we go back to continental drift, we talked earlier about some scientists, senior scientists, who changed their mind. They'd opposed it, say that no, continents don't drift, and then when the evidence came in, they changed their mind and they said yes, the continents do drift. And those are the scientists that have gone down in history. Probably the 2 greatest scientists involved in the continental drift plate tectonics revolution were a man named Wilson and another man named Hess. Longtime opponents. They changed their mind, and they now are the people that you read about. Hess is considered the father of plate tectonics. The people who objected and never changed their mind, went to their grave saying continental drift is wrong. You don't read about them. They've lost their place in history. But I would predict, and I'm going to have to wind up fairly soon
Yep.
here, but this is one of my last predictions. I will be very surprised if any of the opponents of the Younger Dryas impact hypothesis change their mind and say so in public. They should. I'll be surprised if they do.
Well, I appreciate you for giving me your time to do the podcast. And I'm going to link all your links in the description, your website, also where people can find your books as well, too, and the Science Progress article that you wrote as well. It's been a pleasure. Is there anything you want to say to anybody out there listening before we wrap up the show?
Well, I would say trust science. We have a method that ensures that we get as close to the truth as possible. We're right about global warming, and you should believe us.
Thanks for listening to this episode of Out of the Blank.